So let's continue with our trie. On the discussion of this trie data structure, again, so fantastic for looking things up, whether something exists, whether something is smaller or bigger, because again, it does not depend on how many items you have, it only depends on the length of the word, right? Again, the big downside is the space needed for the nodes. So let's try to see if we can actually try, right? Try, pun intended, to make this in C++, right? Let's see if this actually works. Let's see if this works. Will be interesting to see. But in fact, it shouldn't be too hard, right? Why? Because you simply need to save some nodes instead of having two children. You have possibly how many? Let's do 26. Let's do English alphabet, right? Let's do English alphabet for now, and let's see if this actually is feasible. I think it is feasible, right? There should be enough learning material with some simple co-pilot assistance. You should be able to do something, have something working within 30 minutes, hopefully. All right, so try. Let's go. All right. Where's my try? There's no try. There's do or do not, right? But in this case, we are actually trying. So, no. Let's implement a trie data structure. Implement the trie data structure for English lowercase alphabet, right? So we'll have a structure to with a node and trie, and then we'll have actual, right? Again, we will have a Boolean flag to see whether this is actually a word, it's the end of the word or not. So it's like the end of the line, end of the word character. We will also then we will have a trie, array of 26 pointers, right? Why not, right? Right. So in this case, the array index will serve as index of the alphabet, right? You can transform it, right? We'll have constructor to English node, and English course we'll have function to insert a word into the trie. We'll have also for trie, then we will have a trie class represent the actual trie itself. We will have a root node, the trie of course, and initialize. Then we'll have insert. What else do we need? Search, of course, delete. Those are the basics. So those will be insert, search, delete. How about also we will add starts with method to check if a prefix exists in the tree, right? Not necessarily a word. Exactly. I think, do we need anything else for now? I think that's enough for now. If we get this far, that should be pretty good. Maybe you have some suggestions. What else do we need? But let's start with the trie. Let's start with a node. So trie node is end of the world, right? End of the world, but not end of the world, right? So size t. Well, I guess I need to. Again, it's an unsigned integer. I could do unsigned integer, but let's do size t is. We need import. We need to import that. So import include. I mean, not import. Include, right? We need the size t. Right? Include iostream. Include iostream. Yep, of course. Include limits. No. Oh, size t includes that. Includes string. Do we want string? I guess vector as well. Include type info. I don't know why we need that. And include vector possibly. Include vector. Yeah. Let's see. We need. Okay. Maybe we don't need all of this. Hopefully, but we need this. So now size t is right. So the trick. We are not gonna we're gonna use index as a letter basically, right? As a character. But we're not storing characters specifically. We're using this so 0. So 0 will represent a and so on, right? I will represent Z, right? So presence of something, right? Okay. How's your nose going? Who won?
Yeah, who won?
Who won?
Who won?
We did not finish the game.
Did you finish the game?
No, it was way too long.
Okay. Empath. You kept adding those.
Yeah, we
Yeah.
saw no end.
Okay. All right. So yeah. So structure itself for a node, right? It's pretty simple, right? So except the downside. So this is the downside, right? So this is 26. Is end of the node, false. Initialization. So this is the constructor, default constructor, right? Right, and we have no children, right? So false, it's not end of the world, but also we have no children, right? So it's kind of interesting if you make one. Let's see how it's going to be kind of a little bit tricky how we do this, right? We have our node, right? But we want also probably class. Let's make a class now. No, let's make try class. Yeah. Right? Obviously root. We want the reference to root, right? Public, right? That's private. Root is private. And we'll need some methods. We need constructor. Right? Root new try node. Okay. Now what else do we need? Insert a word. So void insert, it's, well, we could have boolean, right? Okay, but so insert word string, right? So we go iterate over C. It could have been, of course, we could have used C strings instead, but it's fine. But you know, yeah. But okay, so now word size, we know this, right? Index. So this is a trick, right? So you find the right place. This is the trick, right? Right. -a, right? Character value, because this is character, so right. Then of course we have the, so if the index has nothing, we need the node, right? And then, right, we keep going, current children index, right? We go there, right? Current, and then, and when we are finished, we set the flag. That's it. So simple insertion is extremely simple. Super simple. That looks good to me so far, right? How about, oh sorry, Control Z, come on, it was there. Wait, Control Y. Control Z, okay, yeah, okay. Now, search. Same thing, boolean, of course, because we're gonna see can we find it, right? So we start at the root. Again, I think I mean, it's beautiful, but sadly not efficient. Again, so as soon as you want efficiency, then it gets more complex. So root, you keep going, looping again, same trick again to get the index of the alphabet, right? And the current children index, right? We return false, right? If there's null pointer, this means that if at any point of traversal we encounter null pointer, we know we have not found. So early return, right? So return early, right? There's no point. I mean, you can't continue, right? There's no way to continue, right? Right? So then we keep going, and then, well, return current is end of the world, right? It's true, right? Well, the thing is, okay, so this is kind of cool, right? So this is also kind of cool trick, right? So notice here. So what we are doing is, if you reach the end of the world, return is the end of the world of the flag. So this means if that word exists in a try, right? We will return true if it is part of longer word will return false word, but not the word just yet. We will return false, right? So this will the flag, right? So we're not returning. So if whatever the flag value is, so eventually we find it, right? Or we don't, right? So there are three possibilities. Either we fail somewhere on the way, right? We keep going, like here, right? We keep going, rad, right? Or maybe rad, we find here, and if the flag is not set, right, it's going to be false. So we look for C, of course, we'll fail early somewhere, maybe bar, we're looking for bar, and there's no A, we fail, so we return early, right? So three possibilities, and of course the best, we find, of course, end of the world, end of the world. I keep asking for end of the world, but end of the world, right? We return the true, and we found it. Okay, so delete. Now delete one. Same approach, but we'll have a slightly. This will be a little bit trickier. I wonder. This is going to be trickier, right? We'll need a helper. Oh yeah. So we delete the word, the root. So this is going to be looks like recursive version, right? Yeah. Okay, so current string word size index. Okay, if index, yeah. So now, if it is not, right? So this is a helper, right? So delete word helper. Let's see how it works. This is a little tricky because I'm pretty sure this is going to be recursive, right? Because otherwise, without recursion, you have to write your own stack, right, and unwind it, a kind of pain. Let's see. So if we reach end of the word, we need to check if the current word node is the end of the word, right? If it's not, we return false, right? The current is not end of the word, right? If it is, we set the end of the word flag, and this is easy, right? Yeah. So all right, if we have not reached end of the word, right? So size check if there's any children, right? So we have to recursively. So this is going to be tricky, right? We have to recursively delete the next, right? Yeah. So this is a little bit tricky, but looks good. So how about the last one? And this will have to go probably over, see if this works. And the last one is easy, right? So how about starts with? Basically, it's just like search, except we are more lenient, right? We simply check in a search. We check instead of this flag, right? If we find it, we don't have to find. We don't return this. We just return true, right? It's basically search, except we are returning true if we find the current end. So finally, no is that. Yeah, it is just like search, except yeah. So this should be really simple, right? Return true, like I said, we return true because we always know, yeah. So we don't care. We do not care whether, yeah. It's true. We know it's a prefix. It starts with, right? So again, obviously, if you say, okay, I want ends with, well, then you need to make a suffix tree. That would be a different thing, right? You could build one for suffix. Other way, right? If you need suffix, again, via memory, you can always trade space for memory. But for now, I think this is good enough, assuming the delete work. Oh, destructor. We need the destructor. Okay, that's probably going to recur. Oh yeah, delete try. Yeah, that works, sort of. Let's take a look. I suppose. Oh, we need helper method. Yeah, I guess so. Yeah, current. So delete try. So this is nice. So nice little what to call how should I say? Nice little recursive calls. Obviously not, of course. So we call recursively on the children. Okay, and so on, right? And so on. Okay, looks okay. Now let's do it. Now let's test it. Let's int main, right? I'll do void for now, right? Or let's do some. Oh no, let's do some letters. Let's add some letters. So let's stay. We will instead of words from argument int main argument count, right? With int is argument count. R count, come on. Yeah, it was argument count, right? Am I doing correctly? Why is it not that? What's happening? Oh yeah, char, yeah, alright. Right. Well, only thing is this is not this of course insert. We want string, and this is not a string. This is of course a char. So I need to probably make a cast with char, right? Let's search. Hello world. This is a test, right? We will delete. Look at methods, right? Let's test the start with method, right here. All right, there's a lot of stuff. I'll start by just simply making things, right? Let's insert and then search, right? Which is kind of obvious, right? Okay, for now, this is we might need to cast. We might need to cast to string here. Okay, let's take a look again. I'm not because this is car. Or we'll take insert. Right, this is a mismatch, type mismatch, right? So we'll see. On G++, right? See, the compiler might say, okay, what are you doing? You're not really doing something good. Yeah, what's happening? Ah, what? What? Ah, sorry. Oh, yeah. Oh, yeah. Flag is it? I'm not on top of my game today. Well, it's surprisingly it compile. I guess I can, but I'm kind of surprised actually. But I guess string it will take. Okay. So let's run it. So try bar bar bane. Okay. Let's try those. See if this works. I don't know. What? I mean, of course. See that is like this. Try bar bane. All right, it found it. Looks like it works. How about looking for something? So looks good. Hello world. This is a test, right? Let's look for those. Right. Oh, looks like we're doing good. Let's see. One second. Okay. All right, so and let's do some deletion as well, right? Look for some hello world. This is the test, right? Hello RTU, right? RBS, right? And let's run it now. It compiled, which is good. And let's see what we're gonna add. Hello darkness, but right. But also, I didn't check one thing, by the way. Are we doing some lowercase things, right? I was doing small letters, right? We should probably, this is gonna break the thing. I'm gonna do, right? Yeah, because this part here, right? Index is fine, but where are we actually getting the index, right? This part here, right? right? This is a very dangerous place, right? So we should probably, these are possibly, we just go out of index, right? And things, dragons fly, right? Not possibility, dangerous place. We might get out of bounds, right? Similarly here, right? All these places. So probably want to when we're doing, we want probably in the insertion, right? We want probably normalize to only sort of like bounds up, you know, do the, right? So that's the thing we want to do. So we'll. All right, we'll finish early again. All right, so. Okay. Let's check. Yeah, this capitalized, would like to, we need to search, so everything should be lowercase, right? Because this currently we can't, right? So for search, for delete, for insertion, right, each time, we need to forward, right? We need to first to be safe, we need to but we need to get lowercase alphabets only. So so check. So if we want to allow capital, yeah. Well, again, so this is cheat. This is a lazy way, right? So index to lower word I, right? And let's see if this will work. Yeah, it should work, right? Yeah, it should work. Yeah. Yep, that should work. This part here, right? To lower, right? Lowercase version of C, right? So this is each place we need to change it. So this is, I'm gonna do this in Control C. Again, I need to do this here as well, right? So this would be nice to make a function of this, right? Get index, right? Since I'm doing it multiple places, right? This would be a good thing to make a function, right? I'm doing so many times, it's possible I make it I do it incorrectly here again. No, this looks fine. And start is search with again. Right. So I think it will work. Not here, but why doesn't it? Oh. Starts with prefix. Yeah, prefix. Okay. All right. So now we should be able to check for RBS, I hope. And then we can finish today. Hopefully. It compiled surprisingly. RBS, RBA, CST, RBS, right? Lunch. All right. So it found RBS, it found lunch. Obviously, is a test. It did not find, right? So we can also find for some words that don't exist. We can start with, right? So it seems to work pretty well, right? And deletion also seems to work, right? So we do check the other ones. Check deletion. To do check deletion. If it works properly, right? But hopefully you got the idea. It's not so hard to implement. So takeaways from this, right? So Control Z. So takeaways. So relatively simple implementation. Downside, large, possible to do. Yeah. All right, maybe share a pointer. All right. Maybe unique pointer, something like that. Some things to consider. All right. will add this to the commit tree. Lots of opportunities for try. Yes. All right. So that is it for today. Any questions on this implementation? Anyone? Does it make sense? Pretty straightforward, right? Just a few things, to, some little tricks of, lowercase things like that, but the indexing, right? Again, just the only problem is that if you have a large alphabet, you end up with a huge tree with, 256 values or even more, right? Million or so on, right? So, all right, so on our last lecture, on Thursday we're going to have a last lecture for the data structures, which we're going to look at. What I have planned previously, but I might change this, right? We had probably I think I'm going to skip Trie. Yeah, skip list kind of cool structure. Yeah, probably skip list, and yeah, this will be the last one on Thursday. All right, thank you.